Ever wondered how your food delivery app talks to the restaurant's system, or how your weather app gets the latest forecast? Why do billions of different apps and services communicate so seamlessly? The secret is a powerful concept we're demystifying today in our REST API Masterclass. So, what is an API? Think of it as a waiter in a restaurant. API stands for Application Programming Interface. You, the customer, are an application, and the kitchen, which prepares the food, is another application or server. You don't go into the kitchen yourself. You give your order to the waiter, the API. The waiter takes your request to the kitchen, and then brings the food back to you. The API is that messenger, that contract that allows different software systems to talk to each other in a structured way. Now, where does REST fit in? REST, or Representational State Transfer, isn't a protocol or a tool. It's an architectural style. It's a set of rules or constraints for building these APIs. Imagine if every restaurant had a completely different way of ordering. It would be chaos. REST provides a standardized, predictable way for the waiter to work. It became the standard because it's simple, scalable, and built on the existing web technology we all use every day, HTTP. This makes it incredibly flexible and easy for developers to learn and implement, leading to its widespread adoption across the web. Let's dive into the fundamentals. The core of REST is built on HTTP methods. REST API commonly use HTTP methods like GET, POST, PATCH, PUT, and DELETE. When you browse a website, you're mostly using GET method to retrieve a page. In REST, GET method is used to retrieve data. To create new data, like posting a new photo, you use POST method. To update existing data, you use PUT method. And to remove it, you use DELETE. Simple, right? There's also PATCH, which is for making partial updates. Every time you make a request, the server sends back a status code. You've probably seen a 400 for not found error. That's a status code. A 200 OK means everything went well. 201 created means a new resource was successfully made. Codes in the 400s mean there was a client error, and 500s indicate a server error. These codes are crucial for understanding what happened with your request. REST is also resource-based. Everything is a resource, like a user, a product, or a post. Each resource has a unique URL, a pattern, like resource/ID. Example/user/3. This makes the API intuitive and easy to navigate. And importantly, REST is stateless. This means each request from a client to a server must contain all the information needed to understand and complete the request. The server doesn't remember anything about the client between requests. This makes the system much more reliable and easier to scale. Now, let's talk about some real-world complexities. What if you need to update 1,000 items at once? Doing 1,000 separate requests is inefficient. This is where bulk operations come in. You can design an endpoint that accepts a list of changes in a single post request, a technique called batch processing. What about actions that don't fit the simple create, read, update, delete model, like publish a draft? For these custom actions, you can create specific endpoints, like /posts, /123/publish. Uploading files is another common case. You can't just send a file in a standard request. This is handled using a specific content type called multipart form data, which allows you to send files along with other data. And when you have thousands of records, you don't want to return them all at once. That's where pagination comes in. The API returns a small chunk of data, say 20 items per page, along with links to get the next or previous page. This is often combined with filtering and sorting parameters in the URL, like per products, sort equals price _ desk, and category equals electronics. Finally, as your API evolves, you need to manage changes without breaking existing applications. This is done through versioning, often by including a version number in the URL, like v2 users. Finally, let's talk performance, because a slow API is a bad API. Cache is your best friend. The server can tell the client how long to cache a response using headers like cache control. It can also use e-tags to check if the data has changed, avoiding re-downloading the same information. Compressing responses with something like gzip can drastically reduce the size of the data being sent over the network, making things much faster. To prevent abuse or overload, APIs implement rate limiting, which restricts how many requests a client can make in a certain period. On the server side, optimizing database queries is critical to ensure the server can find and return data quickly. For static assets that are part of your API responses, like image URLs, using a content delivery network or CDN can offload traffic and deliver content faster from a server closer to the user. And as we mentioned, Proper pagination is itself a performance optimization, ensuring that response payloads remain small and manageable. So, to recap, REST is a set of design principles for creating scalable, stateless, and simple APIs. Using standard HTTP, it revolves around resources, standard methods, and status codes. Understanding these concepts, along with handling edge cases and optimizing for performance, is key to building robust services that power the modern web. Thanks for watching this masterclass. If you found this helpful, hit that like button, subscribe for more deep dives, and let me know in the comments what topic you want to see next.